Welcome back to my channel. Hope everyone is doing well. Let's solve today's Leetcode problem 3349 adjacent increasing subarray detection 1. Okay. Given an array nums of n integers and an integer k, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Specifically, check if there are two subarrays starting at indices a and b where a is strictly less than b. Both the subarrays nums of a and all the way up to a plus k minus 1 and nums of b all the way up to b plus k minus 1 are increasing, are strictly increasing. Okay, the subarrays must be adjacent. Okay, that means if the first subarray starts at index a, then the next subarray should start at index b where b is equal to a plus k. Return true if it is possible to find two such subarrays, else we have to return false. Okay, so they have mentioned that these are the indices of the second subarray, right? So b plus k minus 1, if I choose a subarray which is at the end, okay, that means b plus k minus 1 should be equal to n minus 1. So in this case b would be equal to n minus 1. So the last index at which b, the first index, the last index at which the b can start is actually n minus 1. Okay, since b is equal to a plus k, then a will be equal to b minus k. So a will be equal to b minus k. Okay, so a is equal to n minus 2k. So the last possible index for a is equal to n minus 2 times k. Okay, so we can start a at 0 and go all the way up to n minus 2k. Accordingly, we can, given a, we can pick the b is equal to a plus k, right? So I just, if you look at the constraints, the length of the array is 100. Since the size of the array is pretty low, we don't have to do over engineering. All we have to do is to do the brute force approach over here. Okay, so what I have done here is I have taken n as the size of the nums, and if n is less than 2k, okay, if n is less than 2k, that means this value will turn out to be negative. So a, we cannot choose a value which is in negative, so that's the reason that's not possible for us to choose any negative indices. So we will be returning false over here. So as I mentioned, a will start at 0 and go all the way up to n minus 2 times k. Okay, and we'll increment a step by step. We will be keeping a boolean flag. Initially let's have it as true, and then the first subarray will start at a and go all the way up to a plus k minus 1, right? So I am going all the way up to a plus k minus 1 up to k minus 1 because I have to consider, I am checking the adjacent elements, right? So I have to stop at one index before it so that I can compare it to its next element. Okay, so if any index, if the value at any index is greater than or equal to its next index, that means it's not strictly increasing, then I am making it as false. I am marking that particular subarray as not strictly increasing. And if the first subarray is strictly increasing, then I have to check, then only I have to check whether the next subarray is actually strictly increasing or not. So if the first subarray is strictly increasing, then I will start my I index at a plus k. Okay, and I will go all the way up to a plus 2k minus 1 so that I can compare it with the next element. Okay, if any one of the pair is not matching the given criteria, then I will mark the flag as false. And then if both the subarrays are strictly increasing, that means our flag will be true, then I can return true. If after executing this entire loop, if still we are not able to return, that means there were no two subarrays which are adjacent to each other and not strictly increasing, so I will basically return false. Let's submit this problem. As you can see, it is pretty efficient and it has written most of the solutions. Okay, yeah, the key takeaway here is to look at the constraints and try to solve the problem accordingly. Don't try to engineer to solve the problem. Okay, yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. Thank you.